Now let's look at number 6. In this one, first we're finding all exact solutions, and then we're finding all the exact solutions in the interval from 0 to 2 pi. If you look at this, since this is in radians, that means that we want our solutions in radians instead of in degrees. What we're going to do is solve first for the 3x, because this is one with a multiple angle. And then once we get this, then we'll divide those solutions by 3 to get all of the solutions. First, we're going to solve this for the cosine of 3x by dividing both sides by 2. That gives us the cosine of 3x is 1/2. Since this is a positive value, that means that we would have one solution in the first quadrant. That's also going to be our reference angle for the second solution. Our reference angle is where the cosine is equal to 1/2, and that is at pi over 3. So this is one of our solutions, but we're also looking for another one. This would be the other quadrant where cosine is positive, which would be the fourth quadrant. To get that from our reference angle, we're going to take 2 pi and subtract our reference angle of pi over 3. That gives us 5 pi over 3. Now we have two solutions for 3x that are in between 0 and 2 pi. If we want to write out all the solutions for 3x, we would take these two and put in all the coterminal angles. That means we would have pi over 3 plus 2n pi and 5 pi over 3 plus 2n pi. Now what we're going to do is take this whole thing in order to solve for x and divide everything by 3 on both sides. That's why I write it out in an equation form like this. So if we divide everything by 3, and in here you have to divide each separate term by 3. So if we take pi over 3 and divide by 3, that's actually going to give us pi over 9. And then here we're going to have 2 pi over 3 times n. And then here we're going to have 5 pi over 9 and 2 pi over 3 times n. This would give us all of our exact solutions. Now what we want to do is find all the exact solutions between 0 and 2 pi. We're going to go back to this and find all the solutions from these two that would be between 0 and 2 pi. And what we should come up with, since we had two solutions that were between 0 and 2 pi for the 3x, when we do this and then find all the solutions between 0 and pi just for x, we should end up with 3 times as many solutions as what we had up here. Since we had two solutions here, that means we should end up with a total of 6 solutions that are in the interval from 0 to 2 pi. So I'm going to start with this one and just start writing down solutions. I can do pi over 9, and then if I take pi over 9 and add 2 pi over 3, 2 pi over 3 would be the same as 6 pi over 9, so that would give me 7 pi over 9. And I'm going to keep adding my 2 pi over 3 until I get to something that's more than 2 pi. So I could take this and add on another 2 pi over 9, which is another 6 pi over 3. That would give me 13 pi over 9. That should be all the ones that I'm going to get from this one. I can check that because if I add on another 6 pi over 9, that would give me 19 pi over 9, and that's more than 2 pi. So those are all the ones from this one. Now I'm going to start with this one. So 5 pi over 9, the first one is when n is 0. If n is 1, then that means I'm adding on 2 pi over 3. So I'm taking 5 pi over 9 and adding 6 pi over 9. It makes that 11 pi over 9. And then my third one, I'm going to add another 6 pi over 9. That would give me 17 pi over 9. If I added on another 6 pi over 9, that would get me over 2 pi. So there are my 6 solutions. For part B of number 6, we're going to start out with this one by solving for the 5x first. And this one's a little tricky because it's cotangent. But one thing that you can do with these is think about what would happen if you just rewrote this in terms of sine and cosine. Cotangent is cosine over sine. That means we could rewrite this as cosine of 5x over sine of 5x. And we have that equal to 0. The only way that this can possibly happen is if the numerator of this is equal to 0. So really we can simplify this down to just looking at where cosine of 5x is equal to 0. Well, where cosine is equal to 0, if we're talking in radians, that would mean 5x would have to be either pi over 2 or 3 pi over 2. Now we want to write down all of the solutions for 5x. These are just the ones between 0 and 2 pi. We're going to take these two and write down all their coterminal angles. So we would have pi over 2 plus 2n pi and 3 pi over 2 plus 2n pi. Now that we've got the solutions for 5x, now we're going to divide everything by 5. That would make this a pi over 10. And then we'd have plus 2 pi over 5 times n. For this one, we would have 3 pi over 10 plus 2 pi over 5 times n. Those are all of our exact solutions. Now we want to find all the exact solutions in 0 to 2 pi. Since we had two solutions here, because this is actually 5x, that means that we should have 10 solutions. We should have 5 times as many as this in the interval from 0 to 2 pi. So when we write these down, we should get 5 for each one of these. So the first one would be pi over 10, and if we take pi over 10 and add 2 pi over 5, that's the same as 4 pi over 10, so that would give us 5 pi over 10. I'm just going to write these all down, and then I'm going to go back and simplify them later. If we add on another 4 pi over 10, that would give us 9 pi over 10. Another 4 pi over 10 would give us 13 pi over 10. And another 4 pi over 10 would give us 17 pi over 10. If we tried to add on another 4 pi over 10, we would get to something that's more than 2 pi. So that's where we stop from the first one, and we got 5 of those. That's what we were looking for. From the second one, we would have 3 pi over 10. Then we would take that and add 4 pi over 10. That would give us 7 pi over 10. Adding another 4 pi on the top would give us 11 pi over 10. And then 15 pi over 10 and 19 pi over 10. Those are the 5 that came from this solution. Now some of these you can simplify a little bit. This one is going to simplify to pi over 2. And this one is going to simplify to 3 pi over 2. So altogether now we have pi over 10, pi over 2, 9 pi over 10, 13 pi over 10, 17 pi over 10, 3 pi over 10, 7 pi over 10, 11 pi over 10. This one simplifies to 3 pi over 2 and 19 pi over 10. There are our 10 solutions.